Why, hello friends! Welcome back to part 2 of sequences and series. All right, so in the first part we looked at a pattern of even numbers and asked how do we write an equation to represent that pattern. Pretty rad, right? Makes our lives simpler and way more fun. So in this part, part 2, I forgot the French word for part, but I do remember to count, which is good, I suppose. We're going to be looking at summing sequences and looking at this lovely symbol, this Greek symbol for summation. And so you will run into this a lot. It's particularly helpful in calculus. Don't be worried. Just like when we had to learn what these symbols mean, this is just another of the same thing. So we'll start simple. We're going to build off of the same example that we used last time so that we can understand what's going on. So first of all, I'm going to use the letter S to represent sum because that's what this is telling us to do. We're going to be adding terms on the right side to find the total sum. So that being said, if you see there's going to be some stuff over here, and when you see things on the outside, I'm going to use the letter L for some reason because I like drawing the letter L. When you see something on the outside of the sum, it's almost always written on the left side because this can go on for a long time. Or if you see brackets and then you see like plus 25 or whatever, these two things are outside of our sum. And so what you would do with this is you would add up all of the stuff in here, and we'll get into that in a second, don't worry. And then you would multiply by L, or maybe you have, I have an eraser, I should stop using my fingers. So maybe you have L plus this. Then you would just add whatever L happens to be. Maybe it's 375, or maybe it's negative 15. You would just add that to your result in this chunk. So this is separate from what is in the summation sign. But we're not going to get into that. We're just going to focus on something simple that we did from part 1. So if you remember, we had an equation that looked like this. A1, which is our first term, plus 2 times n minus 1. Okay, so I want to generalize this. And so what I'm going to do is I'm going to say, well, we're going to use our specific pattern where A1 was just 2. And instead of n, I'm going to use an index, which I think I said I was going to use last time and then I didn't. Good times. Okay, so if you've ever done some coding, you'll be like, aha, I. That comes up all the time. So for example, in a for loop, you might say for I equals 0 to I less than 11, I plus plus. And that basically just says we're going to start at 0, we're going to go until 10, or until I is less than 11, and we're going to add 1 to I each round we go. If that didn't make sense and you're like, don't worry about it. We're just tying this language of mathematics to coding, which is super awesome. Because if you learn this stuff, it's easier to do coding. And if you learn coding, it's easier to do this. So they go hand in hand. It's so handy. So sorry, so sorry. Terrible puns. I love them. Okay, anyway, what the heck is I? I is our index. I is how we are keeping track of where we are in the sum. It's basically the term that we're looking at. So when we had our series of 2, 4, 6, 8, etc., this is when I equals 1, this is I equals 2, etc. So this is our first term, our second term, our third term, and so on. So I allows us to keep track of where we are in the sum, which is super helpful because it's pretty easy to get lost. So our starting point goes on the bottom of this summation sign. And in this case, we're going to start at I equals 1 because I get a pick. Since I am the arbiter of this equation, I get to choose where we start, which is pretty rad. I also get to choose where we end, and our ending point goes up here. So I'm going to say we are going to add together 5 terms, or we're going to add our series up until we get to the 5th term, and then we can stop. And I want to know what is the sum of that chunk of my series. You could do this by hand, because we already looked at the pattern, and you're like, I bet I could do this by hand faster than you can do this, and probably. But if you have a more complicated pattern over here, it would be a lot harder and actually more time consuming to have to write it all out by hand. So I'm going to show you how to read this symbol to make your life easier. Yay! Okay, so again, starting point, ending point. Cool. So we go through and we calculate this for each term of I, then we add 1 to I, and we find the next term up until I equals 5. So let's go ahead and do that. So for I equals 1, I'm going to put each of the terms in brackets so we can see the different chunks. So for I equals 1, we get 2 plus 2 times 1 minus 1. And I'm going to write all of this out so we can actually see what it is. So this is for I equals 1. I'm actually going to write this a little bit smaller. I equals 1. Cool. Okay. So then our next term for I equals 2, this stays the same, and so does this. The only thing that changes is I, and now I equals 2, and so that changes this part. And then we add for I equals 3, 2 plus 2 times 3 minus 1. 2 more terms, not so bad, we can handle this. 2 plus 2 times 4 minus 1. Whoopsies, I'm getting my indices all messed up on my brackets. I equals 4. And the last term, 2 plus 2 times 5 minus 1. Oh yeah. I equals 5. Ta-da! That's not so bad, right? So you can see we have 1, 2, 3, 4, 5 terms, just like we expected here. And now what we do is we simplify each of these terms and we add them together. Since I'm running out of chalkboard space, I'm going to do this, I'm going to do some mental math. I am confident that you can follow along, and if it gets too much, you can always pause, think about it, and do the work as we go through this together. It really, really, really helps to actually write this stuff out, because then you'll be like, oh, okay, I get it. Okay. So 1 minus 1 is 0, so our first term is pretty easy because this goes to 0, and we're just left with a 2. Boop. This one, we get 2 minus 1 is 1, 1 times 2 is 2, and 2 plus 2 is 4. And then in this term, 3 minus 1 is 2, 2 times 2 is 4, 4 plus 2 is 6, and you'll start to notice, you're like, oh, this is the same pattern that we just looked at. Yeah, exactly. And so if you wanted to do this faster, you probably would just have picked up on that. But again, this will look different depending on what pattern or what series you're looking at. Okay, so now for I equals 4, we get 4 minus 1 is 3, 3 times 2 is 6, 6 plus 2 is 8, and lastly 5 minus 1 is 4, 4 times 2 is 8, 8 plus 2 is 10. Ta-da! Okay. So I can pull out, or whoopsies. So 10 plus 10 plus, there we go, plus 10. Our sum is 30. Ta-da! Boop. Pretty rad, right? So here's where I also want to pull in another quick thing. So with an arithmetic series, the sum of a series with the n number of terms, again, n is the number of terms that you have, the general equation looks like this, where a1 is your first term and an is your last term. So if you wanted to memorize this equation, cool, it can be very handy. Again, this is the sum of an arithmetic series. So in this case, if n equals 5, let's just double check and make sure that this gets us the same result. So s of n equals 5, we get 5 divided by 2. Our first term is 2. Our a to the nth term is 10. And if we wanted to figure that out, we actually could just plug in I equals 5 for an. Sorry, let me rephrase that. We could plug in 5 for I to figure out a to the 5th term. Or a5 equals, boop, where, yeah, we can run this. And so that's why this is super helpful too, is because for any given term, we can say, we just change the value of I and we're able to find that term very quickly. Very powerful. Okay, so 5 divided by 2 times 12. 2 divided by 12 is going to be 6, so we're going to get 5 times 6, which is 30. My 0 went a little funky. Ta-da! Yay! So that's really awesome. The derived equation is the same as our found equation, or found sum. Yeah, that's a good thing. Okay, so I'm going to leave it there for now. So you can see that this summation symbol is super useful. The one thing that I want to leave you with is that sometimes you'll see a little infinity sign here, and that basically means that you have infinite numbers of terms. So I would maybe not recommend doing that by hand because it'll take you a little bit of time. But sometimes what you'll start to see is if you do it for 5 terms, you'll start to see a pattern emerge. You'll start to see the terms getting smaller and smaller and smaller. And then you can say, oh, okay, well, I can make some educated guesses about the direction that this summation is going in. And then there are also a lot of common series that once we work with a few times, we get the handle of it. And when we see them, we can go, oh, I know exactly what that's going to equal. Cool. If you have any questions about sequences and series, anything that I mentioned in the video that's related, maybe unrelated to that, please, please, please let me know. And of course, if you are interested in other types of math topics, I would love to hear from you. All right, so thanks very much for watching, and I'll see you next time. Bye!